Hey guys, welcome back. As I said, I'm going to scramble this. This is a 4x4 solution that you're going to talk now today, and you'll see that I'm trying to scramble it in such a way that you will not be able to fix it easily. At the same time, we have to go through how these are solved. As you see, the centers are getting distorted completely, and there is nothing that you uniquely can identify as one color in any place which can be considered as a center. So I am trying to. Of course, there are algorithms to scramble it and unscramble it also. So I'm not going through anything. I'm going through the visual inspection to see any adjacent colors. For example, the red and red is there. I just want to spin it out and then see that we don't have. So we have a well distorted or mixed up cube. I hope this is okay at this point with all the scramblings that you're talking. So with this, let's get started. So now you see that it is completely scrambled, this cube, and you're gonna now think about solving this. Now if you imagine this, there is nothing that you can call as a center, there is nothing as an edge. Of course the corners are clearly visible. There are still, if you see that the number of corners remain the same. It was 8 in 3 by 3. Again it is like 1 2 3 4 5 6 7 8. So again 8 in this. Any cube for that matter will be 8 because it's a square based. Of course there are complicated cubes that are beyond the squares, and that they are going to be tougher, and they may not have the 8 corners. It may be more or less depending on the nature, but this is actually 12 side, so it will be like more than that. So for this, first we should need to visualize this cube 4 by 4 as a 3 by 3. How are we going to do that? So unless we come to a point of translating this cube into a 3 by 3, your solving this is going to be complicated. It may not be feasible. So first we need to consider this cube and consider this cube as a 3 by 3. How are we going to do it? So if you see this, you will still have the corners as it is. For each side there are 4 corners, right? This corner, 4 corners, they will remain the same. And the edges, in a 3 by 3, the edges are going to be one piece. Here the edges will be 2 pieces. So if you see the 2 pieces, these will be the edges for the side, and the center will be the remaining portion, which is actually the 4. So if you see a 4 by 4, there will be 4 center pieces. 4 pieces. If it is a 5 by 5, as you can see, I'll just show you for reference. 5 by 5, again we should translate this as a 3 by 3 by using the same method. This 3 by 3, inside this will become the center, these 3 will become the edges, and this one piece will become the corner. So any cube that is beyond 3 by 3, we are going to translate that into a 3 by 3 model. So for 5 by 5, you will consider this entire portion as 3 by 3. This has the center, this has the edges, and these are the corners. And as I said, 3, 5, 7, all those things has a center. Again, here you cannot tamper with the center. The center piece is already fixed. So you know that when you see this, the other thing should be red. You know this white, the other should be white. The center cannot be moved. Whereas in 4 by 4, you have nothing called as a center, because this can become green, this can become yellow. All the 6 colors are possible. You can fix anything. So you should just be careful not to miss that. So what I normally do is I take the yellow as the first and then keep it on the top, bring the orange next as the front, and then keep this as a base. This reference point will give you that green should be on the left hand side, blue should be on the right hand side, the red will be on the back hand side, and the white will naturally fall on the bottom. So this is going to be the orientation of a normal cube. Okay, so yellow and orange, green will be on the left, blue will be on the right, red will be on the back, and white will be on the bottom. So we will fix this, and all the numbers beyond 3, 4 by 4, 5 by 5, 6 by 6, the complexity increases corresponding to the number. For example, 4 by 4 is slightly complex, 5 by 5 is more complex than 4 by 4 to bring these cube into the correct positions like center, edge, and corner. And the same way 6 by 6 is much more complex because the number of pieces that are there inside are more, and any distortion that we do for any one piece can tamper with all the other ones. So that being the case, we should focus on getting this right. So what we need to do is, at this point, again I'll take a small break and then get to the next clip. But prior to that, the idea is make the center, edge, and the corners and translate this into a 3 by 3. That is the first step for us to make the 3 by 3 solution implemented by a 4 by 4 cube. Okay, with that explanation, I'll take a small break and come back with the next clip. Thank you.